Hello everyone. In this video we're going to be solving an exponential equation. Well, the left hand side is exponential, the right hand side is polynomial, so it's kind of like a non-standard type of equation. But the left hand side is exponential, so let's go ahead and call it exponential. We have 1 over 3 to the power x equals x plus 4, and we're going to be solving for x values. And I'm going to present two approaches. I don't know if you can call them two methods, but let's see how that goes. So my first approach is basically looking at the left-hand side as a decreasing function. Why? Well, this is a decreasing function. In general, y equals b to the power x is decreasing if b is between 0 and 1. Obviously, you don't want b to be negative. You don't want it to be 0. You want it to be positive. So there are two options. Either b is like the logarithm, right? B is between 0 and 1, or b is greater than 1. So in this case, b needs to be, and our b is, which is 1/3, falls in this interval. And you know that the graph is going to look like roughly something like this. As x approaches infinity, y is going to approach 0. As x approaches negative infinity, y is going to approach positive infinity. And it has a y-intercept at 0, 1. And no x-intercept because of the asymptote. Anyways, so that is a decreasing function. So what about that, right? Well, if you look at the right-hand side, you get y equals x plus 4, which is an increasing function, because it is a line with a positive slope. You know, it's easy to graph. For x equals 0, you're going to get y equals 4. For y equals 0, you're going to get negative 4. Find the intercepts and graph it. Okay, this is increasing, the other one is decreasing. Therefore, they will intersect at a single point. Now, a lot of times when we have problems like this, we kind of guess and check the solution, especially if we know that there's only one solution. And once we guess it, we're done, right? But I'm going to use a more analytical approach here. We're going to dig a little deeper. Okay, so to narrow down our possibilities. So first of all, notice that if x is positive, if x is greater than 0, then 1 over 3 to the power x. So now notice that if x is 0, it's going to be 1. If x is greater than 0, like for example 2, you're going to get 1/9. For x equals 3, you're going to get 1 over 27. So the number is going to get smaller and smaller, and it's always going to be less than 1. And if x is greater than 0, we know that x plus 4 is going to be greater than 4. Wow. So the left-hand side is less than 1, the right-hand side is greater than 4. That means there is no intersection here. There are no solutions on this interval. So for positive x values, we do not have a solution, which is good to know, right? Obviously. And what about x equals 0? Well, let's rewrite our equation. Okay, our equation was 1/3 to the power x equals x plus 4. Obviously, for x equals 0, there are no solutions. So x equals 0 is not a solution. Great. The only option left is negative values. So we're hoping to find something. Otherwise, we're going to say this equation has no solutions. For x equals, for negative x values, if x is less than 0, we have 1/3 to the power x. Now notice that if you raise 1/3 to a negative power, like -1, -2, -3, you're always going to get a number that is greater than 1, and x plus 4 is always going to be less than 4. Great. So the left-hand side is greater than 1 and the right-hand side is less than 4. Therefore, we have to check the intersection, which exists. So our y value, of course, in this case, either this or that, because they're equal, right? It has to be between 1 and 4. Great. So we're basically going to be looking for a solution in this interval. Can we find one? But let's dig a little bit more. So 1 over 3 to the power x can be written as 3 to the power negative x. Interesting. Isn't this a power of 3? Well, sort of. If negative x is a positive integer, well, that means x is negative. Great. And that's what we just talked about. So when x is negative, 3 to the power negative x is going to be a power of 3. So we're only looking for a power of 3 on this interval. The only power of 3 between 1 and 4 is 3, right? So the y value, which I refer to as it, must be 3. This implies 1 over 3 to the power x equals 3, which means x is equal to -1. But if x is equal to -1, or if 1 over 3 to the power x is equal to 3, that means x plus 4 is equal to 3, and that means x is equal to -1. Yay, they both check. Great, awesome. So x equals -1 is definitely a solution, and guess what? That is the only solution to this equation. All right, awesome. Now, let's go ahead and look at the second approach. Now, the second approach is basically looking at this equation from a different perspective. And this is what it is. So I'm going to put everything on the same side and turn it into a single function. Now, since I'm solving for my original equation, I want to find the values for which f of x is equal to 0, right? Okay. So I mean, in other words, I'm looking for the y-intercept. Is that correct? Okay. Y equals 0 means x-intercept. Never mind. I'm looking for the x-intercept. Okay, great. So now, let's go ahead and look at it from a calculus perspective. I'm going to go ahead and differentiate this function. Remember, to differentiate b to the power x, what do you need to do? Uh-oh, that's kind of like a weird way of writing it. Okay, how do you differentiate b to the power x? Well, you just write the same thing and multiply by ln b. That is the correction factor, because you can write it as e to the power something, and then e to the power something. You can differentiate it, so on and so forth. Anyways, so when we differentiate it, it's going to become 1 over 3 to the power x, and I have to multiply it by ln 1/3. Awesome. And then derivative of negative x is -1. Derivative of a constant is 0, so I don't have to worry about it. So this is the derivative. Why am I looking at the derivative? Because the derivative of a function gives you information about the behavior of the function. Is this function increasing, decreasing? Where is it increasing or decreasing? Like on which intervals? And you can find the maximum, minimum points. You can find inflection points, so on and so forth. But notice that ln 1/3 is negative ln 3. So we can write this derivative as negative ln 3 multiplied by 1 over 3 to the power x minus 1. So for any x value, notice that 1 over 3 to the power x is always positive. This is always positive. We're subtracting 1 from it, so don't worry about it. But ln 3, since 3 is greater than e, ln 3 is going to be positive, right? I mean, greater than 1. What am I talking about? But when you multiply by negative, that's going to be a negative quantity. In other words, this f prime thing is always less than 0, which means that your function is always decreasing. F of x is always decreasing, meaning that it can only intersect the x-axis at a single point, and you can easily guess that solution, which we already did, right? We said that, yes, x equals -1 must be the only solution. Now, let's go ahead and take a look at the two different graphs here. One of them is the first approach. Notice that -1, 3 is clearly an intersection point. And then the second approach gives you the following function whose derivative is always negative, which means it's always decreasing, and this is going to be our solution. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.